So basically what we wanted to do was develop these wheelchair analogs or WAMs that we can fit a wide variety of wheelchairs. And with these WAMs, we can collect environmental data that will allow us to develop assistive control behaviors. And we'll have to tell you a little bit more about them.
So part of the motivation for this project was that some physical and mental disabilities are coupled, and so they're not able to use conventional, regular powered wheelchairs, such as falling downstairs or things like that. So we wanted to remedy that situation with a cheap or cheaper sensor package. And the other thing is we wanted to make sure that different types of wheelchairs could be placed with different types of modules. This is because most physically disabled don't have enough money in order to do any type of full ground-up renovation and actually buy a full new wheelchair. So we build all these modules, and then we would be able to exhibit this assistive behavior.
So most of the hardware that's on here was developed this year. We have these sensors, which are analog IR ultrasonic rangefinders. We have the encoder modules, which were developed for measuring wheel rotation. This was one of the biggest challenges because you needed a way to get reliable odometry data, so you can accurately measure velocity and position and things like that. The problem is most power wheelchairs don't come with that on the modules. The problem is I can't attach the encoder test because there's no axle. If I want to do a gyroscope, it's going to be very inaccurate on the outside. So we did install encoders in this block. To do that, we had to drill the back of this motor block, put a shaft in there, epoxy it, and then make sure it was stable, which is not a good solution. It's not anywhere near an ideal solution. So, if you actually have checked out the, what was the wheelchair called?
The Neo wheel.
Yeah, the Neo wheelchair. Compared to this one, the placement of the motor block on the wheel it's not exactly the same, but it's the same overall design. It's just different distances. So with this module, you place it on the motor block, it can slide in this direction. So if the wheel was further forward, then you can slide it forward.
Highly configurable.
Very configurable. If the wheel was further out, you can go further out. If it's further in, you can do that. So it allows us to fit the different variety of wheelchairs.
So anybody can do that, really.
Right.
So if that came in a kit in the mail, how long would it take me to bolt that on and dial it in?
We actually we did a overall system build test, which is actually in this video here. So we have a time lapse of assembling the whole thing, and to get all this on from the ground up took about 90 minutes to assemble everything from the ground up. So it's very so I don't know exactly how long it takes us to just add that.
Okay. So then the other thing is, how do we come to the solution? So first of all, we had to identify our stakeholders and get our needs and generate all these. Basically, we only really used 4 stakeholders for this. The locked-in individual that's inside the wheelchair themselves, and a couple of different ones. One that we wanted to specify was different robotics engineers, because we wanted to build subsystems that would subsidize the cost of the overall system, such as the sensor.
So the sensor network itself, it's very, very customizable. It's if you want to really load it up with sensors, you can get up to 750 sensors on it, which is it's a huge amount of capacity. So you can fit, almost anything can use that number of sensors. If you don't need that many, you don't have to add that many. So we can give you a hardware. So this is the core hardware for the sensor network. So what it is it's an app microcontroller on a custom design board, which is designed to allow different types of sensors to plug into it. This is an ultrasonic sensor. It runs on 3.3 volts. You want some IR sensors too. This one's a 5 volt. You can't plug this into 3.3 volts. It doesn't work. So you can plug this into these slots.
So you did Atmel, why not an Arduino board?
Because we wanted to deal with the firmware on the Arduino mostly, and because we wanted to be able to customize this as we need.
What's your major?
ECs.
And robotics.
Oh, well, I'm also robotics.
In robotics.
All of you?
Robotics. Okay. Yep. So another thing we wanted to do was to communicate with the computer. So we did this module, which is USB to UART. Microcontroller talks to UART natively, so you can talk to the computer over a serial port.
How many serial ports do you have on your computer?
You have 127, so it's a USB as long as you have.
You have how many serial
Not
ports?
ports.
Not ports.
We
use sensor. We use hubs.
USB hub. So as long as
Do you want to show them?
So you're doing the UART to USB translation where?
On this module. Okay. So you buy the module, so you don't have to
And then did you cut this with a laser?
Yep, laser cut.
What did you use to draw that up with?
SolidWorks.
Almost all, actually all of this was done in SolidWorks. The headrest mount itself, the different mounts under here, was all done in SolidWorks. And then we also created the board, threw the board in SolidWorks to make sure we had a full working module.
The actual traces were done in multi-sim. It was pretty quick. It was an easy circuit design. So the goal is to make it as useful as possible to as many different stakeholders.
So this box, roughly idea cost.
25 cents.
No, with the electronics in it. This
With everything.
module.
As a one-off or in large volume?
No, in volume.
Okay, so in volume, so one-off cost of the board is $33. In volume, that would drop to a lot less than $33. I don't know the exact number. We didn't actually do
You got an app mail on there, USB to UART, bridge,
and then
the rest of it.
then
Some IO.
Yeah, so some canvas.
$83.
Maybe a little bit more, and depending on the volume you do. So this goes from like $40, $50 down to $3 with a larger volume. So as a one-off, it's very expensive.
Yeah, everything is.
Yes,
But now these sensors, what could you do this for? Okay.
So it was mainly for protection. So originally
No, the whole this
the sensor.
in the box, everything.
Anything you would, any situation where you would need to collect range finding data and then interacting with the real world.
How much does it cost?
Right.
So
No, what could it cost?
what could it cost in volume? Well, the sensor stuff. I didn't actually look into the large volumes of this. The sensor as a single unit is about $27 for the ultrasonic. The IR is about $11. It's a sharp IR and a max plus. Okay, so we didn't actually look into that cost. But in large volume, the overall cost would most certainly go down.
So I think we're running out of time, but we should show you some of the assistive features that we were able to do.
Run it, baby. Run it.
Actually, want to take the poster off and show them?
Yeah, sure, that's fine.
So we can show that it track a wall or a flat surface.
jump in.
More fun. Yeah, actually, let's pull away from the table.
Okay.
So you can show the proximity as you approach someone.
That would be done. Okay, ready?
That's a safety violation.
So I'm going to pull away.
So here, look at the controller.
So if I let go of the controller, it'll basically, he's going to kind of steer me away from the wall. Most of the time walls don't move, so it's not too big of an issue.
So the main selling point is that if he's driving at this wall, I don't want him to be able to.
Right, it's just
So
going to steer me completely. So
yeah,
we put that at an angle in front. I'm gonna start back here, and we have a couple different types of the system control. The first one is proximity. So notice I'm gonna start to slow down as I get near it, and it's gonna make me slow down. I'm keeping the same velocity and also turn. So now I don't ever have to worry. The other thing is I'm in proximity of you, so now I can't actually hit you. So we'll actually allow me.
So here, why don't you let's show him.
So different types of proximity control.
Slowly into
sure.
so just drive. So he's driving at constant
Full
speed.
speed.
It slows down.
It slows him down as he gets closer.
So if someone's walking in front of you in a congested hallway,
Let's just test it. So here, I'm gonna walk. I'm gonna cut him off. I'm gonna be an asshole. Cut him off. All right. Are we out of time?
No, 2 minutes of presentation.
There you go. All right. So here.
We'll step out of the way here.
so
Yes.
Yes.
So
It's a solenoid.
node going off.
So
I'm going.
extract your fire.
You got it. So I can't actually hit people. And the real thing about these sensors is that they are in this network. It's not a high-level network, but it's a quick decision-making, reactive, low-level artificial intelligence that we're able to implement different types of behavior.
So there's the selling point of that. This is very capable. It can do mapping. It can do image detection. But this is much slower.
Okay, so that's the area detection.
Yes, and also, well, this side you can't see down here at all. So we need more blind spots, and it is that you want this to act independently of your mapping and navigation, because if one of these nodes fails, then all of a sudden you've lost that safety feature. It's a separate system that you couple.
So this system is run on the Atom?
No, it's not. This system is running on. It's running on a Intel laptop. The main reason we decided to not go with the board, one is because it came so late.
You broke things up.
Yes. So it is so.
The tight loop, real-time control. It's a little more higher functionality.
Yep. Correct.
And this,
Multi-threaded.
So I mean, right now it uses a good amount of computing power. We have reduced it, so we're working on getting it off the laptop and onto a smaller platform, like the Atom board, maybe an Intel NUC. But it's smaller, and you can just attach the robot here. We're seeing this. Yes.
So right now now there is no atom board.
No, there's no atom board. The main reason is that we want to use a robot operating system to run it, and the Yocto Linux on the atom board is not supported. Well, so last week's platform I think ran Fedora, and that does run ROS. So we were hoping that if it ran Fedora, we could actually get it. Yeah, but it's usually the hard if you're on any sort of hardware that has zero connections to low-level stuff like this over USB.
Do you come across conflicts with that sensor?
So what does this sensor do? I missed that.
This one generates laser scans, and we can use this for higher level. We don't really use it for our behaviors right now, but for the future, we're able to actually generate maps of indoor environments, and with those maps, we can localize ourselves within them. And then say for example, we want to go to the kitchen. Well, we might have a button button says, I want to go to the kitchen, and the wheelchair will know where it is, know where the kitchen is, and know how to get there.
Or with that headset, you can put a voice command, right?
Exactly. I mean, the headset. Yep. I mean, you could. The sensor is the headset is designed to accept a wide variety of sensors. So if you wanted to even add stereo vision in the future, you could do that as well.
Some of the cool things about this headrest is it features wire management all throughout, ribbing throughout the entire thing, allowing you to customize it.
It's also detachable, so if you don't need these pieces from the system, you just want this, it's got screws, you can just pop it off, and that cuts back into your house. If you don't need that piece.
The actual piece in here is very easily made, so you can create a bunch of variety of these type of things depending on what's widely used and pop them in.
Was this an automatic wheelchair when you started modding it?
So what do you mean by
just a
automatic?
regular power wheelchair.
Power wheelchair.
Yeah, so it's just a regular power
It looked
wheelchair.
like a power wheelchair. I was just curious.
Yep, it is.
Okay, so you guys are three young strapping men. What motivated you to create add-on modules for people with disabilities?
So Ross is a personal story.
So one reason that we first started was Professor Peter actually came up to the three of us and asked us to work on this project for him. But the reason we ended up doing the assistive control and things like that was because I found how cheap and how well this had been made originally, and I really wanted to help my family. Personally, one of my family members who's mentally and physically handicapped couldn't move around the house, and someone always needed to be with her. But it would have been really nice to have increased her ability while she was good. So
I guess the overarching benefit is that if you don't need the mapping, you can give this network to someone with Parkinson's disease and their handshake, and they tend to drift towards walls because they don't have very good control of a joystick. It won't be perfect, but it will assist them in that regard, make it safer for a larger variety of conditions, not just the one that the overarching project is designed for, which is someone who has no control over their body at all, so they're physically locked in but have full cognitive capabilities.
Even if you've got full cognitive capabilities, maneuvering a motorized wheelchair is not.
I'm not sure if you mentioned it, but we actually, when all the behaviors are put together, we have assisted navigation through doorways. And navigating through doorways is one of the hardest things a person can do, because if they don't get it just perfect, they got to back up, start all over. So with this, all you can kind of do is point in the general direction, and the wheelchair self-aligns, gets you through just fine.
And that does it by slowing down in the front, and then once these sensors come in range, it's able
That's
to
what I mean. Yeah,
do a perfect
Once you
trajectory.
get.
And yes, I've realized, we tried driving around the first time we got it. I mean, you're flying on these things, and they're very difficult. This actually allows you in a crowded area to kind of keep you.
Well, I was just thinking, even if you're just in your general purpose facility, elderly facility, you don't want to be running grandma over in your wheelchair.
I'm driving straight at the door. It'll turn me on. So if I didn't trick myself, then I would crash into the wall. And we actually did some testing on this earlier in the year. We had this power wheelchair without modifications to it, and then I had a manual wheelchair, and I drove it around for a little while to get an idea of what difficulties encompass being in the wheelchair. And doorways is a huge, huge part. If you don't get it just right, you have to back up and start all over. And that can be just frustrating.
Do you make doorways an autonomous?
It's not semi-autonomous.
You just have to hold forward. So if you want to go forward, it's kind of.
It's going to figure out how to get you through.
Yes, and
that is cool.
That behavior stems from the wall following. So and the lines, and the lines display. The fact that it will turn you parallel to walls to one head, and doorways between your walls. That it was emergent. It actually programmed that in.
It was also emergent because doorways don't open all the way, like fully, you know? So even though it's technically wall following, it's actually matching your doorways, which is perfect, because that allows you to get this kind of curve. So as soon as you're following a doorway and then you see a really close wall here, it's going to actually push you out parallel to it. So it ends up making this nice smooth trajectory going through. Which was a surprise to all of us. We were just adding these different types of behaviors, and all of a sudden it's like, what?
So this is very important. How long did it take for you? 7 months. 7 months.
So we first went through like the stakeholders and all of our different types of things. We actually had tons of different ideas on how to do that. And we threw these into weight charts, we did some research, see how long research and development would take, see how long it would be able to actually configure the different types of wheelchairs. And we actually came up with this with a higher rating than most of the others by quite a bit. And when we built it, we did multiple iterations, but 2 fully designed prototypes. And once we had the final prototype, we strapped it on there and it just worked. And it works just as well as the encoders in the shaft. That's actually shows right here. Here's actually the comparison between the two. We found that this one actually matched the speed better than the shaft encoders did. And that's because we actually have to know the parameters of this without that.
So one of the problems is that these wheels are textured, which will affect how you can speed. The shaft encoder is just rotating motor, which has no idea what it's doing. So by having at lower speeds, that texture is going to be more defined on the wheel that rotates outside. You're actually going to see those speed changes from that slight difference. So it's only at low speeds that's significant, but at the higher speeds it matches very exactly with the actual.
But with more code,
you can make it even better. Yeah. Right. So it's all about
Filtering.
yeah.
Cool thing is too, you don't even need to know the actual diameter of the wheelchair wheel. It abstracts it out for you because we have a set 2-inch diameter wheel that collects the odometry.
Oh. Oh, okay.
So
Okay. Oh, okay. I see what you're saying.
do you guys have connections into the wheelchair industry?
So one of the problems
When this is over, hunt me down. I think you guys have something here. You don't get greedy, because I think people who need this, cost is an issue. I can turn you on some industry.
we actually have a TED talk. We haven't TED talk in October. Oh yeah, positive. I think I contacted us and said,
Yeah. Very much. No, thank you. I think this is a good.
Yeah, that would be. See, that's you need to expand. Because people, just general purpose. My dad's 86. Running into.
Yeah.
He's in a motorized wheelchair.
We tried it for my cousin for that brief time, and we took it right out of the house. She went through it half the wall. So
So the problem with commercializing is that you have to go through a whole lot of regulations that you didn't have time to do. So next year's budget team will add even more features and possibly looking to increase the IRB.
So you're seniors. So what's the motivation to keep going on this?
We're graduating.
The next
keep
year.
going.
So we're off the project at this point.
There's another team.
Yeah, so it's a 4-year project.
You're the first. You're the first of 4 years.
You guys did a lot of work in the last 7 months.
So is this hardware or software? Aldrin? Looks like it's software.
Probably cut you guys off.
Oh, sorry.
We're a minute over.
So
FPGA or embedded software?
so software on the controller is very simple. It takes in the command from the serial